When we first looked at the sine and cosine curve, we discussed the properties such as the period, the amplitude, the maximum values, and the midline. In this video, we are going to look at properties of sinusoidal functions that have been transformed, and we're going to use both the graph and the equation to learn how to identify these properties. In this first example, we are given the equation, the sine function, and we are given the transformed graph. So let's use the graph to find these properties and then relate it to the values in the equation. So first, let's look at the period. To find the period, we're going to choose a point on the graph. So an easy point would be a maximum or minimum. So here I'm choosing a maximum point. And then I'm just going to highlight one full cycle of that curve. So I started at a maximum and I end at a maximum because after that, the curve starts to repeat. So now I will use the scale to determine how long it takes for this one cycle to occur. It is always useful to know what one interval of your scale is. So here, 4 intervals gives you 90 degrees. So if you take 90 degrees divided by 4, you get 22.5. So it's always nice just to write one interval is 90 divided by 4, which is 22.5 degrees. Just looking at where that maximum occurs, it looks to be about half an interval after 0 degrees. And then the next maximum is about half an interval after 180 degrees. So it takes 180 degrees to go from one maximum to the next maximum. So therefore, the period is 180 degrees. You should remember that in the base sine function, the period was 360 degrees. And we know that it's the b value that affects the horizontal stretch and compression. So by looking at that equation, we can also determine the period. So we can take the normal period of a sine function, which is 360, and just divide by that b value. So 360 divided by 2 is 180 degrees. So we found it from the curve, and you can find it from that b value. The maximum and minimum values are pretty straightforward to find from the graph, but you may find it useful to draw a horizontal line at the top of the curve and at the bottom of the curve. And then we can see that that maximum value is 2 and the minimum value is -4. We are not able to simply identify the maximum and minimum value from the equation of the curve, but there is a formula that we're going to look at to tell us how we can calculate that. The midline, if you remember, is the line that cuts the curve in half. So if the minimum is at -4 and the maximum is at 2, there are 6 intervals in between, -4 and 2. So the midline has to occur 3 intervals from either side. So at -1 is that midline. That is worth drawing. It's always worth drawing the midline. When identifying the midline, as it is actually a line, we give it an equation. Here it's y equals -1 because it crosses the y-axis at -1. And looking at the equation, this midline is actually just the v value, because if you remember from the base sine curve, the midline is at y equals 0 along the x-axis, and it is shifted down 1 unit. So now it is at y equals -1. It is the v value that tells us how we vertically move up or down. So the midline is just the v value. And finally, if you remember, the amplitude is the distance the maximum is from the midline, and it's also the distance that the minimum is from the midline. If the midline is correct, those two distances should always be the same. And here we notice that the maximum is 3 units above the midline, and the minimum is 3 units below the midline. So that means that the amplitude is simply 3. And if you look at the equation, you see that the A value is 3, and that makes sense because the A value is the vertical stretch. So instead of the base curve just having an amplitude of 1, it's stretched, so now it has an amplitude of 3. It's important to note that the A value can be positive or negative, but the amplitude always has to be positive. So the amplitude we say is the absolute value of A. So if A was a negative value, so just say it's -3, the amplitude would still be 3 because it's a distance above or below that midline. You do want to know how to identify properties given a graph. But there are also formulas that we can use to identify properties, and these will become useful as we get into application problems. So we're going to do another example where we identify properties from the graph and from these formulas. So in this example, we have the transformation of a cosine function. We're going to identify the properties from the graph here on the left side, and then verify the properties using the formulas, and I'll do that here on the right side. So to determine the period, I'm going to figure out the length of one cycle. So I'm going to highlight one cycle of the curve, and I chose two nice points. Again, I chose from a maximum to a maximum. So just like in the last example, one interval is 22.5, and I got that by dividing 90 divided by 4. So we can see that the cycle ends at two intervals after 360. So if one interval is 22.5, then two intervals is 45. And also you can think of half of 90 is 45. So that means between 360 and 450 is 405 degrees. Then I want to figure out what this value is over here, and it's 45 degrees to the left of -270 because it's two intervals to the left of 270. So that is -315 degrees. So to go from -315 to 405, that's 720 degrees. And you can do that 405, take away -315. When you take away a negative, you add 315. So that period is 720 degrees. So you could also notice that the maximum where the cycle starts is two intervals after -360 degrees, and then it travels to two intervals after +360 degrees. So again, that's how you can get your 720 degrees. Using the formula, the period is 360 degrees, which is the period of the base sine curve, and you divide that by the b value. Here, the b value is 1/2. So we divide by 1/2. Remember that when you divide by a fraction, you multiply by the reciprocal. So that is 360 times 2, which is 720 degrees. So I have drawn the horizontal lines at the maximum points of my curve, the minimum points, and then the midline in between. And that's going to help us identify the next few properties. So we can see that maximum value is -2, and then that minimum value is -4. If we want to identify the maximum and the minimum from the equation of the curve, there are two formulas that we can use. The maximum is v plus the absolute value of a. What this means is the v, which is the midline. We already talked about how the midline is affected by v, so the v value is the same value as the midline. So we take that midline and we add the amplitude. The absolute value of a is the amplitude. So you take that midline and then you add how far you are above that midline. And same with the minimum. You take the midline, the v value, but this time you're going to subtract how far you are away from that midline. So the maximum is the v value. So here the v value is -3. And then we add the amplitude. The a value is -1 because cos is being multiplied by -1. So we're going to add the amplitude, the absolute value of -1. If you remember, the absolute value of a number means it always has to be positive. So we get -3 plus 1, which is -2. And then the minimum, again, you have the v value of -3, and now we're going to subtract the absolute value of -1. So it's -3, take away 1, which is -4. So the next thing to identify is the midline, and I have already drawn it on the curve. It's that purple horizontal line, which has the equation y equals -3. So we can easily find the midline from the curve. Also, we can find the midline from the equation, which is the v value of -3. But in the application problems that we're going to move to, you might only be given the maximum or minimum of a problem. So you're not going to be given the equation or the curve. So there is a formula you can use. And basically the v value, which is the midline, is just the average of the maximum and minimum. So you just add those two values together. So the maximum is -2, and you're going to add the minimum of -4 and then divide that by 2. So that's -2 take away 4 divided by 2, which is -6 divided by 2, which is -3. So the amplitude we have already discussed when we were trying to find the maximum and minimum values using the formulas. But from the curve, you can see the amplitude is the distance that the minimum is away from the midline and the maximum is away from the midline. And we can see that that is simply 1. We also talked about that the amplitude is the absolute value of A in the equation. Here, A is -1. The absolute value of -1 is 1. Again, if you are in an application problem and you're only given the maximum and minimums of a curve, there is this formula that you can use. So the maximum we know is -2, the minimum is -4. We want to find the distance between the maximum and the minimum and then cut that in half, and that's the amplitude. So now we will find that the amplitude, absolute value of A, is the maximum, which is -2, take away the minimum, so take away -4, divided by 2, so that's -2 plus 4 divided by 2. -2 plus 4 is +2, divided by 2 is equal to 1. And the last property we need to identify is the phase shift. Remember, the phase shift is simply the horizontal shift. So it's just the h value from the equation. So we can easily find the phase shift from the equation of 45 degrees to the right. Remember to use the opposite sign, so it's positive 45 degrees. To find the phase shift from the curve is actually quite tricky. What we do is identify if this is a sine or a cosine function. This is a cosine function. We know that on the base cosine function, the starting point is a maximum. So at 0 degrees, there is a maximum. So what we would do if A was positive is look at where the new maximum is. However, in this case, A is negative, which means there's a reflection in the x-axis. So this maximum actually becomes a minimum when it's reflected. So what we are going to do is look for a minimum on the curve, and that minimum occurs at 45 degrees to the right. So that point is right here. So there is a phase shift 45 degrees to the right. Again, the equation, it's easy to identify the phase shift. The curve is trickier. We are going to go further into this in the next lesson.